Hello guys, welcome to our YouTube channel Signal Flow Labs. Today in this video we are going to talk about Arduino Uno and its brain, obviously Atmega 328P. So in this we are going to cover a lot of topics about Arduino Uno, how to program it and everything in detail to understand the basic concepts from scratch. The first topic that we cover is memory. What are different sort of memories that are available in Arduino Uno that you can use and how you can basically program them. The second topic would be digital and analog pins. How many pins are available, how you can program them, and etc. Third topic will be communication protocols that are available in Arduino Uno, like I2C, SPI, UART, and all sort of communication protocols. And the next topic that we'll cover is going to be power and voltage management systems that are there in the Arduino Uno, how you can customize them and use them. And the last topic would be timer and counter controls. So let's get started with the first topic, that is memory RAM that is available. As you can see on the screen, the photo of the Arduino Uno, there are 3 to 4 memories that are available in it. The first memory is SRAM. So this memory basically stands for a memory that is only used as a controller to store its data that are on temporary basis. It stores the data and gets wiped out eventually. Let's give you an example. Storing sensor readings of let's say you're using sensor of temperature sensor, you get a reading from it, you get it live. But once you reset the power of the Arduino Uno, you don't get the reading anymore. That's what is SRAM. It stores the data for a point and then deletes once the power off. And that's what memory is available in Arduino Uno is 2 KB. Then the second one is EEPROM. That is 1 KB memory that's available. That can be used basically, if you can see, for setting data, Wi-Fi credential, that gets permanently saved. It's a non-volatile kind of storage. So it gets permanently saved into it, and that can be used for Wi-Fi credential and can be used again. The third is a flash memory. That's the most important one. So basically, whenever we flash the code into this, 32 KB of flash memory is available in Arduino Uno that we used to flash the code, to run the code, and basically store that code in the Arduino Uno. So it doesn't get lost when you power on and off. So it stores the entire code in it. Then this is 8-bit processor. So basically it can process 8 bits of data every second. That's what it is. And then we're going to talk about different prospects in it. And let's take forward. Started with timers and counters and clocks that are available in Arduino Uno and Atmega. So in Arduino Uno, there are 3 types of timer available. The first one is timer 0, timer 1, timer 2. Now these are divided into 8-bit timer, 8-bit timer and 16-bit timer based on their application and use. So timer 0 is used basically in functions where you want to put a delay into the code, in which millisecond delay, 1 second delay, all sort of delay is used. Timer 1 is used for servo motor precision control, in which you use basically servo motors or other you want to control. That time you use timer 1. And timer 2 basically is used to count interrupts and everything. So if I have a code in which I have to count number of times it was interrupted, number of times it detected a value, that time we use timer 2 and initialize it. As you can see on the screen, there are 3 options available on the timer, and then you can basically visualize them one by one and understand them thoroughly, how they are functioning. And you can see all this flash memory, all these things that are available on the right side of the screen. You can basically see them and visualize what I'm talking about at Atmega 32. Let's get started with the third topic, that is analog and digital pins. So as you can see on the screen, there are different pins that are available on Arduino Uno. 2 of them are analog pins and digital pins. So analog pins are the pins that convert basically analog value, that is from 0 to 5 volts, to a scale of 0 to 1, 0 to 3. So they are used to read the analog value from a sensor. So I'll give you an example. If you have used temperature sensor, soil moisture sensor, so they give an analog value from 0 to 5, and that you can basically plot it on your PC based on 0 to 1025. So it's a 10-bit ADC module. That's why it converts to 0 to 1023, and that way you can basically visualize it. So if you can see on the screen, you get the analog value that's from range from 0 to 2. So basically 0 to 5 volts is divided into 0 to 1023. So every 0.1, 0.2 volt stands for some sort of amount of this, 100 and this. So in that way you can basically divide and get the exact value on your screen, on your Arduino, as you can see on the screen. And as it's a 10-bit ADC converter that's available on Arduino Uno, you get from 0 to 1023. If it was 12-bit, it was 8-bit, you'll get different values based on that. The pins that are available on Arduino Uno are A0 to A5, and those pins they are only input pin, they don't give ADC output. So these pins are only used to get ADC input from the sensors, from the other or applications. They can't give basically ADC output. You can't, that's not possible. They are just there for take the input. Second sort of pins are digital pins that are available in it. Now there are multiple pins in Arduino Uno that's ranged from 0 to 13. There are total 13 digital pins in it. Now digital pins basically are just pins that gives output from 0 and 5. So basically it's 0 or 1. Either it's 0 volt or it's 5 volt. That way you can just program them. They can even take digital input as well. As compared to analog pin, these pins can take digital input as well. They can take input as well as give output. So digital pins can do both the things. So they take input from 0 to 5, detect it and give it. So there are threshold voltage, let's say if it's about 2.5 volts, it detects it's a digital yes. If it's below 2.5 volt, it detects it's digital no. And that way you can do. In those pins, there are certain marks you can see on the screen. Just mind the mark that is there, that is used for PWM. So all the pins in Arduino Uno can't use PWM. What PWM stands for is basically, if I want to give an analog value to a sensor, light, bright LED, then at that point I have to basically vary the width of the wave of the digital pin, so I can vary that voltage. So it's basically high frequency output comes into picture. So if you can see on the screen, that's visible, and in that way you can basically manage it off. There are certain pins in Arduino Uno that are there available on it. So those pins are 3, 5, 6, 9, 10 and 11. So total there are 6 pins that are there for PWM pulse. Now the output that we get, the frequency that we get of the digital output on PWM, there are different outputs available. So 480 Hz is a default setting that is used. So all the rest of the pin give 480 Hz as PWM, but pin number 5 and 6 give 980 Hz of PWM output. So in that way, as you can see on the screen, all these things are available, and you can see and you can get to know what digital analog pin actually means and how we can basically use them. Yeah, let's talk about the next topic, that is communication interference available. So if I'm not sure if you guys know about, but there are 3 communication protocols usually that we use. First is I2C, SPI and UART. So starting with I2C, there are 2 pins required, basically SDA to send data and SCL to send the clock frequency. So every MCU that we use or microphone that we use have a certain dedicated pins for that. You can't basically use any digital analog pin for that. There are dedicated pins that are function in such a way that you can use those. So on Arduino Uno, A4 is determined for SDA and A5 is determined for SCL. So you can just program it using those pins. It's basically depends on it. Based on the clock frequencies of Arduino that we have 16 MHz, it can vary depending on it. So there are 2 pins available. The second one is UART communication. So UART communication, there are 2 pins, if you might know, to need to communicate. That's through TX and RX. So TX is pin number 1 and UX is pin number 0. So in that we can communicate UART communication if you want to do Arduino. So when you're dealing with certain sort of communication protocol in Arduino Uno or otherwise, you're going to make sure that all these pins that you have initialized or declared in the datasheet of that particular microcontroller, you have to use them only. If tomorrow I connect, let's say, pin 3 to TX and pin 4 to UX, RX, it won't work basically. So we have to be assertive and we have to be firm that what we use is the dedicated pin. So before assigning pins based on your requirement of the project or anything, refer to data sheets and understand what are the pins output that are there, so you can understand them better. As you can see the photo on the screen, you can clearly visible that all sort of this SGA and all this is determined on the screen itself. So you can basically understand them. You can browse through internet and get it easily. So whenever you go for it, that's what I suggest to do it. Then there are SPI portals. So SPI means that is MIOS, that's pin number 12, MOIS, that's pin number 11, SCK, pin 13, and slave select, that's pin 10. And the speed that we use for this is 8 MHz. The different pins that are already allocated for it. So talking about power management and regulation in Arduino Uno. So power is, so there are three ways to basically power on the Arduino Uno. First, you can use USB that you can directly run to your laptop and app starts. Then there is a DC jack that you can use to supply 7 to 12 volts of DC input to it to start the Arduino Uno. That's one way to do it. The second one being D input, that's available on the Arduino that you can see on the left side of the board. That board takes an input from 7 to 12 volts. There is an inbuilt voltage converter that is available that regulates the 7 to 12 volts into 5 volts, that is power supply given to it. So that you can use So V-in pin that you can see, in that you can basically apply any volt from 7 to 12. You can use a 9-volt battery, any sort of battery, and you can power on the Arduino Uno. So there are 3 ways in which you can basically power on Arduino Uno. If you're doing a project outside, somewhere else, you can't connect USB to it. So the only way that you can do is you can connect V-in directly to a battery and then you can power on it. Many people, how much I've encountered, they don't know this part, they just get confused how we can connect it. And so V-in a very, very basic thing. So it's a 70 to 12 volts, an ampere current that you can handle it. There's one more regulator that's available on board, that is 3.3 volt regulator. So it gives 3.3 output. So as you can see on the pin diagram, there are 2 grounds available, 5 volts available, and 3.3 output. So this 3.3 output you can give to various sensors and everyone, because every sensor works in a different way. They start running in a different way. Some sensors require 5 volts, some sensors require 3 volts. So in that way you can see it and you can change accordingly and use it. And the max current per input pin can be 40 milliamps that we can use. So you have to take in consideration what milliamps current that is given to the input. Sometimes if the output from a sensor or from a basically circuit that is more than 40 milliamps, then it's going to damage the Arduino Uno board. So in that scenario, you have to use resistors, capacitors, other kind of circuits. You can put resistors to decrease the current and everything, so that it doesn't harm it. So when you're dealing with microcontroller, you have to be very precise on what are the current controls, what are the this, and then you have to do it. So in this video, we have talked about Arduino Uno, SPI memories, and all sort of available options that you can do to make it work properly. So this was a basic video about how Arduino Uno functions, what is ATmega32. In the coming videos, we are going to talk about how to blink a light. We are going to share codes with you along with other factors like projects that we have built on Arduino Uno, how to function them using timer clock. It's going to be very interesting. So this is not just a channel that is used for beginners or advanced. Everyone can watch it. Everyone will be able to learn how it's function, what they can do, and how they can do it better. So that's it. So subscribe to our YouTube channel. Thank you for watching.